In this section, we'll look at the configuration of a hypervisor or a virtualization host. You will learn the steps to installing and setting up the host operating system, the hypervisor software. You'll learn about the importance of certain BIOS configurations like hardware-assisted virtualization, processor configurations as well. We'll talk about sizing the virtual host in order to make sure that we meet the needs of the individual guest operating systems. And this is going to include CPU, memory, as well as network interface cards. So now that we've discussed what the hypervisor is and how it interacts with the computer, we need to understand the virtualization host that runs the hypervisor software. The virtualization host is the system that is installed first, and then it, quote unquote, hosts guest virtual machines. The host server runs the hypervisor software and provides all of the underlying hardware and compute resources for the guest virtual machine. And this is going to include memory, CPU, hard disk, and network I/O. Now, since that host machine is providing resources for the guest, it has to at least have enough hardware resources to meet the minimum requirements for the virtual machines. And so we're going to discuss sizing. The virtualization host computer also allows different operating systems to coexist on the same host computer. So you could have a virtual machine running Windows Server 2012 and another virtual machine running the Linux operating system, and that would work just fine. Remember, it also allows for multiple applications to coexist that may not be compatible with one another. And this is because those applications can be running on different virtual machines. Now, before a computer can successfully function as a virtualization host, there are going to be a number of hardware prerequisites that the computer system must meet, along with having an adequate number of resources. Okay? I believe earlier it was stated that these virtualization hosts are potentially going to be much larger machines when it comes to computing resources than their physical counterparts. Where a physical machine that's functioning as a domain controller could probably get away just fine with a dual-core processor and a couple of gigabytes of RAM if that's all it was doing. Your physical hosts that are virtualization hosts are going to have multiple CPU cores, gigabytes and gigabytes of memory, multiple network cards, access to multiple hard drives for storage, and this is because they are hosting multiple virtual machines. So they need to have enough resources to allocate to the guest operating systems, but there are also some key configuration options that are going to be required. The first of these configuration options that's considered a prerequisite for your virtualization host is something known as hardware-assisted virtualization, which essentially is just a feature that enables efficient and full virtualization. So it's used to simulate a complete hardware environment or virtual machine. It's basically software that allows the hardware to provide support for the host computer to run guest operating systems or virtual machines. And in a sense, it just makes virtualization more efficient by utilizing hardware capabilities that are built into the host computer's CPU. Both AMD and Intel are going to support hardware virtualization. And this is something that you need to look for, okay? Now, it's also something that it's much easier to find these days. So 10 years ago, when I was looking at computers or we were ordering computers, we accidentally ordered some systems for a classroom that did not support hardware virtualization. The difference then was a $30 difference, and the individual who was doing the ordering just failed to investigate why there was a $30 difference. Well, one supported the virtualization and one didn't. And so we ended up with nearly unusable computers because we needed the virtualization aspect. These days it's much less likely for you to encounter that. Of course, a good place to start if you're trying to figure out whether hardware supports it would be the AMD or Intel websites. Both are going to have a list of all the processors that support hardware-assisted virtualization, and pretty much all processors manufactured after about 2004, 2005 will have hardware-assisted virtualization. So as I said, at this point, it's kind of a moot point unless you're trying to use older hardware. There's another aspect beyond hardware-assisted virtualization, and that's in relation to the BIOS. Of course, the BIOS is built-in software that comes with the server. It's built on either a ROM chip or a flash memory chip. And the BIOS, the basic input-output system, determines the feature sets that are available to a computer without that computer having to access any additional software, or without the BIOS having to access any additional software. So for example, the BIOS can contain software that's needed to control the keyboard, the display, hard drives, USB, power options, and other options. It can allow the computer to be booted up by itself if the hard disk on the computer fail or if they are corrupted. So what does the BIOS have to do with virtualization? Well, it plays a key role in enabling virtualization on the host computer. In order for a machine to act as a host and have the ability to host guest virtual machines, the modern operating systems will actually rely on the BIOS to support hardware-assisted virtualization. Okay? Some of your older systems may not have this feature in the BIOS at all. Other older BIOS might require a firmware update before the feature can be enabled, but most of your newer model servers from different manufacturers, as well as the latest desktop computers, would support this. It's typically, no longer necessary to even have a host machine that's running server class hardware, because most of the desktop hardware now natively supports hardware assisted virtualization. So it's a very important feature. It's just as the growth of virtualization has come along, we're having to worry about it significantly less. So now that we've looked at hardware-assisted virtualization, the implementation of BIOS configuration settings, it's time to look at actually configuring the host. Those are important things, but so is the sizing of the virtualization host. We need to make sure that virtualization hosts are properly sized to support at least the minimum number of virtual machines. Each of these virtual machines are going to require a certain set of hardware, and they're going to require certain levels of hardware based on the operating system and the application that they are hosting. And so sizing the virtualization host makes sure that we meet those particular needs. Of course, the first step is purchasing the correct type and number of processors for the virtualization host. We need to consider a number of things. The first would be to consider the speed. And we might think that speed is really one of the number one considerations, but that's actually not necessarily the case. We might consider multiple cores instead due to the ability to spread out the CPU load. A multi-core processor is simply a single physical CPU with two or more independent CPUs called cores, and this is very common today. And generally speaking, virtualization, you're better off spending money on more cores with more cache rather than on faster CPU speeds. All right, so if, for example, you had to choose between a system that had a 12-core CPU running at 2.2 gigahertz or a system with a 6-core CPU running at 2.9 gigahertz, the 12-core CPU is going to be better because you can spread the virtual machine load across the CPU cores, which that's just going to translate into faster, more consistent virtual machine performance. All right. Once we've defined the processor for the host computer, then we need to figure out how are we going to assign CPU resources to the guest virtual machines. Now, not surprisingly, the guest virtual machines are going to use what are called virtual CPUs or vCPUs, and those can be added to a virtual machine when it's created. The number of the virtual CPUs that you should add is dependent on a number of factors. It's also not possible to assign more virtual CPUs to a system beyond the cores, okay? I take that back. It is sometimes possible. It kind of depends on the virtualization platform, but you need to be careful doing that. So if you're assigning more virtual CPUs, then there are physical CPU cores. You're sort of in a tricky proposition. You need to evaluate the workload of everything before you're doing that. Most of the time, it's safe to assign 4 to 6 virtual CPUs for every CPU core on the server. But we have to look at documentation. We need to look at the requirements of the particular applications. We need to consider calculators. You're going to have some, for instance, where this don't work. Okay, so for example, a heavily used SQL server, database server, is going to be very processor intensive. So in that particular scenario, you would probably want a 1-to-1 CPU to virtual CPU assignment. So you have to take everything in stride, and you need to look at all different aspects of this, of the scenario, including the operating system and the application that's going to be hosted. Once the organization has decided which CPU and how many CPU cores they're going to purchase for the host, the next step would be to plan the amount of RAM or memory that the host machine is going to need. And planning the amount of memory is certainly different from planning the number of CPUs. CPU resources can, in some cases, be oversubscribed. More virtual CPUs than you have physical CPUs, and that's not the case with memory. It's much harder to oversubscribe it. So planning memory is critical. The more memory, more RAM that you have, the faster the RAM speed, the better it is going to be for the virtualization host. Now, note that some platforms will allow you to adjust virtual machine memory on the fly, allowing one virtual machine to borrow memory from another VM without shutting down the system. But other platforms will require the systems to be shut down in order to alter the memory configuration. So just keep that in mind. In fact, the older virtualization programs will typically require you to shut it down. Some virtual machine platforms will also provide dynamic memory allocation. So instead of having to statically configure the amount of memory that you have on the system, you just specify dynamic. You specify a minimum and a maximum, and we'll see this when we look at the actual virtual machines, but specify a minimum amount of memory. That's the minimum it will have when it starts up. You specify a maximum. It will never exceed that, but then beyond that, it allows the host and the hypervisor to fluctuate the amount of memory that the system has. So dynamic memory allocation, unless it is not supported by an application, is a very flexible way of doing it. At that point, I really just need to carefully plan those minimum and maximum values, because we don't want to run into a situation where a virtual machine takes way too long to start up because it doesn't have enough memory. We also don't want to run into a situation where all of a sudden we are exceeding the amount of physical memory that we have, because while that can function, if the machines are already up, it can result in problems like operating system and application crashes. It can also result in just excessive paging and very low performance. So we need to look at the total amount of memory that we have. We need to identify the memory needs of each individual virtual machine, and then we need to configure it appropriately. Another area that is very important when it comes to sizing virtual host are the network interface cards. You might not think of this, but a NIC is very important. Choosing the correct network card itself, as well as choosing the configuration, and it's all important. So let's start with the card itself. In order to achieve the best possible network performance on host computers, organizations should only use server class NICs. All right. It's also important to identify and verify that the infrastructure between the source and destination NICs does not include a bottleneck. In other words, we need to make sure that everything is matched, the speeds along with duplex settings. Okay, so for example, if you're using a 10 gigabit NIC and you're connecting to a 10 gigabit port on a switch, you need to make sure that all your patch cables support 10 gigabit speeds, and the switch is configured to use 10 gigabits as opposed to not being hard-coded to use 1 gigabit speeds. Basically, you're always as slow as the slowest link in the chain. So, having a misconfigured switch, having a lower category cable, that can result in a bottleneck, which can result in slower performance. So, correct choice of card, correct configuration, those things are all important. Here are a few configurations that you may not think of, but they are specific to, or they're specifically used in virtualization environments. The first is checksum offload. This just offloads the process of TCP packets to the actual network controller. So it's offloading them from the CPU to the network controller. So that's just a configuration that's turned on. TCP segmentation offload, also known as TSO, converts large chunks of data into smaller packets to be transmitted through the network. That's what segmentation is. Offload is, once again, putting it on the network controller as opposed to the CPU. 64-bit DMA, or direct memory address, permits high throughput and low latency network. Jumbo frames extends Ethernet to 9,000 bytes. That's definitely a term you want to know. That just allows for less packet overhead on the server, fewer server interrupts. 9,000 bytes on the actual frame itself, which is about double the size of the norm. And then the final one is called large receive offload, LRO. This is used to increase inbound throughput, and it does that by reducing CPU overhead, basically aggregating multiple incoming packets from a single stream into a single memory buffer. Some of these are very technical. If you want, I'm mentioning them just because they're important to understand. They are all just configuration options on a NIC. Do you have to know exactly what it's doing? No, not necessarily, other than it's increasing performance. So if you want, you can look at a little bit more information on those, but as I said, they are just simply a configuration option that you need to enable on the NIC of the virtualization host. So in all of these areas, we need to make sure that the virtualization host is configured properly to, number one, support virtual machines, and then number two, provide the correct amount of hardware and compute resources for those virtual machines to function properly. In this section, we discussed configuring the virtualization host or hypervisor. And you now understand that the configuration of the host is incredibly important because in order to achieve many of the advantages of virtualization, we must adequately plan out and configure the host machine. Certainly, we talked about the fact that the host would need to meet certain prerequisites and have a particular operating system. Some of those prerequisites were hardware-assisted virtualization that utilizes a configuration built into the computer's CPU, which both AMD and Intel support, as well as BIOS, hardware-assisted virtualization. We then discussed sizing the virtualization host as it relates to CPU, memory, network cards, and doing so very carefully in order to support a certain number of guest operating systems that are performing particular functions within your environment.